All right, and it looks like that we are live. There's a little bit of drop frames, but that's because we've updated our network, so we'll see how well this video goes. All right, so today we have ourselves a MacBook Pro 15-inch. It's a A1398. Specifically, the board number is an 82033. 32. This one is an interesting one that I did want to do a live stream on because what's going on here is the board, you can kind of already see the measurement that I took here a second ago, is pulling an amperage of 0.28. Now, from my experience, that close to 0.3 amperage consumption is usually a sign of a CPU failure, or CPU has just completely died. Went ahead and first thing I did was measure to see if we even had CPU vCore. It did not look like that was the case. Didn't even seem to be present. One thing I haven't done was to make sure that our CPU wasn't shorted to ground. So let me go ahead and get a measurement of that real fast. And we have a resistance of 1.1. Now, these boards do have a very, very low resistance. I would have to compare it to a donor board just to make sure that that is normal for this specific processor. But essentially, if everything looks fine, compared to the donor board that we have of the measurement of 1.1 ohms, then at this point, we're just going to have to go down our list of power rails and see what is or isn't present. And that's the exact same reading we are getting on our donor board, is a resistance of 1.1. So in this case, it looks to be that this specific processor for this year is just going to have a very, very low resistance. So let's go ahead and move forward with the board repair. What I want to do with this is just go ahead and start up by opening up our schematics. I've already went ahead and pulled it up here. And what I want to look at specifically is going to be our power aliases, and just kind of work our way down from our PP bus, PP3V3, or PP3V42, 5 volts, things of that nature. So let's go ahead and open up Paul Daniel software and just do a quick search for power aliases. And here we are. So let's check and see what our PP bus is on this specific computer. And get our power supply ready and make sure that our software for our power supply is properly turned on. Okay, so you can see, right, so we are pulling 0.28 and it's just kind of staying there. So where is PP bus located on this specific computer? We have a fuse down here close to our keyboard connector. So let's go ahead and get a measurement of that real fast. So PP bus is 1.9 volts. That is way too low. So PP bus looks like that something is either pulling it down. All right, so that's a good hint right off the bat. So I kind of want to look and see, are we even getting a proper voltage on our DCN right here, our PP18V5 DCN connection, or PPDCN G3 hot. Okay, so we have an inrush limiter right here, and I've actually ran into this issue before where this inrush limiter can go bad, which can cause PP bus to pull lower than it actually is. So let's plug up our power supply and switch over to our microscope camera and take a look over here. And so the components that we can measure for our PPDCN is going to be over on this side. And let's see what we have. 18.3. That is close enough. And let's actually take a look here on this inrush limiter, Q7080 on our schematic, to look at both sides. So what the inrush limiter does is it takes charge from our charger, and basically it's almost like a safety net. It even says right here, reverse current protection. From my understanding, this is actually to prevent power from going back up into the charger itself. And sometimes this can partially fail. And when that happens, then PP bus doesn't work like it's supposed to, or at least it gets partially pulled down. So on the other side, PPDCN G3 hot inrush limiter, let's measure and see what we have. And we're still getting about 18.3, so that's normal. So PPDCN G3 charger is going to be fine as well. So eventually PP bus is going to be where our issue is at. So what I'm thinking we can try in this instance is we can remove this fuse and check and see if we're getting the proper, what's the word that I'm looking for here? I guess we could probably, this was the fuse that we checked out here. No, this is a different fuse. 7040. Basically, I wanted to see, are we getting proper power on this side versus on the PP bus side? And that would be the charger phase. Where are you located? You're right above our battery. And it looks like there's just a piece of cotton. Nothing conductive. Let's go ahead and disconnect our charger just in case. So those little white components, those are our fuses. And the fuse is nothing more than just a wire. So let's see what we have on this side. 1.9, 1.9, that's pretty consistent. So the fuses themselves aren't blown. So what exactly could be pulling down our PP bus? What I'm going to do next is, before we continue further, I'm going to go ahead and pull the board out, just so we have a little bit more mobility. I'm sorry, it's been a very, very long past couple of weeks. We're starting to get into our busy season too, so I haven't really had the time to do much repairs, honestly. My staff has had to do most of the repairs while I take care of administrative work. So it's come to the point I can really only do board repairs, or let alone any repairs, at night. So we're very grateful for that we've gotten to that point. I am pretty excited because we have a new tool that's going to be in here on Friday. We got the One Eye, created by La Clínica de la Manzana and Shiny Computers. It's going to be a attachment for our microscope to where we can get multimeter readings in our microscope lens itself. So we've already ordered one of those, and if you wanted to check it out yourself, go to logi.wiki, and it's going to be the first thing at the top of their page. And you can purchase it from La Clínica de la Manzana, which is just Spanish for the Apple Clinic. And check it out yourself, and let alone just check out the video. It's been a homebrew project that a couple of different engineers got together and made. I'm just excited to get my hands on one of them. I would have loved to have had one of them whenever I started doing board repair in the first place. After doing it for so long, kind of just picked up how to use my peripherals to view the multimeter readings. But if starting out, if I was able to get the multimeter readings in the scope itself, would have been able to work just a little bit more efficiently in the beginning. Once I get mine in, I'll learn how to use it and probably do a little video on it. But yeah, really excited to see that come in. I really miss when these computers were more prevalent because you just had to use one T5 screwdriver for taking everything apart. The newer computers, you have to have T5, T4, T3 pentalobes in order to fully disassemble. But this all just comes apart with one screwdriver. And we have one more screw that's holding down the heatsink. Alright, so we have our logic board out. And let's set the rest of our board components, the rest of the computer itself, to the side. Alright. Let's give this thing a quick visual examination just to make sure there isn't any weird signs of liquid on it. First, we'll need to get our microscope in focus, and I am looking for suggestions on a new microscope camera, or maybe just a C-mount lens, because you can kind of see on the right side of our image, everything's fine, but over here on the left side, because my C-mount is not fully flush, it kind of goes out of focus. So any recommendations on either a C-mount or a camera, I'm definitely all up for. This has been a great camera. I only paid $70 on eBay for it, probably about 2 years ago at this point. But I may have to move it to a different microscope and try to upgrade this one. Okay, no obvious signs of liquid damage on this side of the computer. Alright, so as far as the visual inspection goes, this computer looks fine. Now that's completely out of the housing, let's see if we get a change. 0.28, so it's still consuming the same amount of amperage. So we need to figure out now, is PP bus being shorted either from that inrush limiter beforehand, or is there something further on down the road that's not working? I'm curious if... let's take a look back. Oh, we're definitely starting to drop some frames here for a minute. Definitely need to get our streaming computer up and running again. We've just been so busy, that's one of those side projects I haven't been able to dedicate time towards. We passed the page. Now, if our PP bus isn't present, I'm pretty sure we're not going to have 5 volts, but I just need to give myself a refresher here for a moment. So this is our U7201, and we're supposed to have about 5 volts right here on this specific capacitor, and it's about 1.1, which makes sense just because our PP bus itself is so low. So, to kind of cheat here for a moment, I want to see if I have any pulsing on PP bus. And what we're going to do for that is use our thermal imager, which tends to run like poor quality whenever we're doing a live stream. Well, let's see how it wants to play with us tonight. Yep, and as I suspected, it's just really poor. And let's see how choppy the computer gets now. All these drop frames. Okay, so I'm seeing things that don't look good. Alright, so by hooking it up to our thermal imager, we can see we are generating a lot of heat, which looks right next to a CPU phase. Let me see if I can flip this over. It's just taking a really long time. Okay, so we are pulling, or we have about 43 Celsius near some coils close to our CPU, which is not a good sign because, as mentioned, the 0.3 is usually a sign of the CPU itself failing or something potentially killed it. And let's go ahead and take a look. We can say thank you to the thermometer for giving us a clue of where we should be looking. And I accidentally closed out our schematics. Let's pull that up. Hello, Zentech. Thanks for joining us this evening. So most of our heat was being generated in this area around these coils, which is going to be our PPV core graphics. Alright, so I'm going to take a look real quick because most of the heat was also around these capacitors, which are connected to PPVN S5 high-side GPU ints. So everything so far that we're seeing that looks like was getting warm, and this is just a hint that it was helping us out with, is going to be related to graphics. So, thanks to the Please Bro camera, I'm just going to get a reading on these capacitors real quick and see what we are as far as ohms go. And we're reading about 13 ohms on that capacitor. Now, that seems a little low. We're going to compare that real quick to our donor board and see what that capacitor should actually have a resistance of on that specific line. It's a PP bus line, which makes me think something is not supposed to be that low. So compared to our donor board, we can see that we are in the kiloohms. All right, so our hint here is that something on this specific line, in fact, does that look like a crack or is that just adhesive? That looks like that may just be adhesive. Something on this specific line for our PPV and S5 GPU ints is potentially shorted or partially shorted. Q8930, which is in the same area of where a good bit of our heat was coming from. So let's take a look at this and see exactly what this is. That looks like that is some sort of transistor that is responsible for PPV and SO GFX IMP, graphics IMVP. I'm not too sure what the IMVP stands for off the top of my head. So now what I want to do is I want to get another look by after peeling this stuff off and just kind of see, one, if there's anything obvious, two, if we can probably see exactly what was getting hot, because the thermal imager really couldn't see with that piece of tape over it. All right, so in the general area, nothing too obvious. Now these coils right here, we're definitely getting a little on the toasty side. These coils are connected to PPV Core SO graphics phase chips. Which has a resistance of about 14. And when compared to our donor board, let's check and see what that coil is, that line is measuring. So that's normal. Okay, so where our inconsistency here is going to be on our flipping it over real quick, I already forgot the name of the line. PPV and S5 high side GPU ints. Okay, so things are going to get a little choppy here again. I'm going to switch back over to our thermal imager and hook up our power supply and check and see what is getting warm now. Where is our software? Here it is. And let the drop frames commence. All right, so we can see something's getting warm over here. I want to compare this side of the board to the other side and check and see what temperature it's getting. Zentech says, I also do component level repairs. How did you get started? I actually just practiced on a whole bunch of boards that I couldn't repair at the time. Now, what I mean is if a board itself was completely destroyed, I would replace the logic board for the client and hold on to their original board and check and see if there was a way that I could repair that board. I would even buy broken boards from various places and try repairing them and see if I could restore them with the collection of boards that I had acquired over the years. All right, so we can see this almost looks like that Q, I already forgot the name of it. Let's pull it back up real fast. Well, let's pull it up as quick as we can. This transistor, the Q8930, seems to be getting pretty warm. Yeah, we're getting 44 Celsius around. So now let's flip it over and check and see what our temperatures are on the PPV and S5 GPU ints. And we can see we're generating a lot of heat over here too, 44.1. And we had about 43 on the other side. So now the question is it a matter of these capacitors here have partially failed, or is there something wrong with that specific transistor that we had, the Q8930? 44.9 and climbing. Let's see what we flip it over, what the other temperature is. And whatever is hotter, I feel like is going to be your issue. And here we're at 45.9. So this side of the board is about 1 Celsius warmer. So let's take a look and see. We need to get this out of Chinese or Mandarin. But it doesn't look like it can do that since we're doing a stream right now. So this button right here point exactly in non-thermal mode what we're looking at. And we're just kind of using the Pt1 camera here to help us cheat, but this has really helped us with a hint to figure out where PP bus is being partially pulled down. And it's just not wanting to cooperate. So I'm happy enough with this result. Let's go ahead and just turn off our thermal imager software because we can't really stream when it's turned on. So this seems to be where temperature is most prevalent. Okay, everything's starting to come back. And this side of Q8930 is also connected to PPVN S5 GPU INTs. So I'm going to say at this point, we just need to go ahead and pull off Q9030 and see if we alleviate any of that, what's the word I'm looking for? The low resistance we have on that specific line. So what we're going to do is very close to both our CPU and our GPU. So we don't necessarily want to hit this thing with rework air because we could do a little bit of damage. Maybe heat up some of the solder balls underneath the GPU. And another thing that we can do that would help out is to use some micro tweezers, and we're going to heat up both sides of Q8930 at the same time while using a rework at a low temperature. What would probably be best too is to remove the heatsink, because the heatsink is going to dissipate the heat that we put on it just as fast as we put on it. Its sole purpose is for cooling down the board. And being that we don't want that area warm, do we have a ground on that side? Actually, it does not look like we have a ground on that side. Just for safe measures, I feel like that we should just go ahead and remove this anyways. Besides, it is an older computer, so it would benefit from having the thermal paste replaced after the fact anyways. So let's turn on our fume extractor and remove this heatsink. Your channel is going to blow up, trust me. Thank you. I'm just a guy that records my jobs. If it brings in a little bit more clientele, I won't be opposed to that. All right, set that to the side. And now we had to get our tweezers ready because we were last in micro pencil mode. So I apologize for those who are listening to headphones. Oh, nice. It didn't beep at us. Or it didn't scream at us, I should say. And being that I want to apply as little amount of heat onto this board, instead of pulling... Being that this is probably our issue, what I'm going to do is go ahead and get another board, our donor board here, and I'm going to pull off Q8930. That way, if it does turn out that we alleviate some of our resistance being pulled down, or our very, very low resistance, yes, I know that you're dying, Then, while the board is still warm from us heating it up, I can quickly transfer a new Q8930. That way the board doesn't have time to cool down, and then we have to heat it back up, and boards don't like being temperature stressed like that. All right. Excuse me. So to help melt the solder, because Apple uses unleaded solder, we are going to go ahead and just put some of our solder on the pads right here. That way when we heat it up, it should help melt the solder from the factory with our low melt solder, just kind of mixing the two together. Well, should be enough for now. And let's use medium temperature here and try pulling this all up. So what I'm trying to do is heat up the general area at the same time while I heat it up with my tweezers, so that we can kind of pinpoint or isolate our heat without having to apply too much heat near the graphics processor. I'm also using a smaller tip nozzle for my rework station. That wasn't on purpose, but it is helping out here. I had just used it last time for an audio IC we repaired earlier today. Now this component may take a little bit longer to remove than it will on the actual patient board, just because I still have the heatsink on this computer, so it's very possible that the ambient temperature is being dissipated as quickly as I'm applying it. So we have our Q8930 off of our board, just in case if it turns out Q8930 is in fact our issue here. The reason I wanted to do that again was because I am going to heat up this board, but I don't want to heat up this board too many times. Let's set this on the side. And now back onto our patient board. Going to do the same method where we apply some low melt solder. And this time, instead of using my tweezers, I'm going to try just a normal iron that's got more surface area, so it can heat up these pads a little quicker than my micro tweezers could. Because you can see the board right here, it's actually not melting my solder. And the reason for that is because the iron is just not heating up the general area quick enough for the solder to get to melting temperatures. The board is actually absorbing the heat just as quickly as I apply it. Alright, so let's go ahead and see if we can pull this off. And if this is going to alleviate our resistance to ground. Because on our donor board, we were in, I think, like the 5,000 kiloohms, or I guess it'd just be 5 kiloohms. On this board, it was about 13 ohms. So something's being pulled down here. And you notice this this component looks identical to the inrush limiter we had for our PP bus too. So it seems like whatever material this is made out of, or maybe just the design of it, is known for... Ooh, you see this? It left like the ground pad behind. Huh. I would say that was our issue. Interesting. I've never actually seen one melt like that, to the point that it actually destroyed itself on the inside. So we just removed the top casing, but we still have the inside that we're going to have to remove. So now I feel more confident after seeing that Q8930 was our issue here. All right. Fantastic. Now we gotta somehow pull this up. Now it's just breaking in pieces. I've never seen one of these explode like this, which worries me because it's exciting that this confirms our issue. Did it damage anything else in the process? This is a transistor that is going to be part of our and should I really say transistor? It looks more like an inrush limiter, but according to the schematics, it's definitely some sort of transistor or MOSFET here that goes to graphics power. First time I've seen this. Same here. I've never seen this before. Let's apply a little bit more flux because this is all charred, and I don't want to pull up on any pads and have to run any jumper wires. Not on one of these things. This one in particular, there we are, was super charred. Alright, so let's just kind of clean up the area now. Trying to limit my rework airflow since we are still fairly close to the GPU. Okay, and we got all the big chunks out of the way. Now my concern is it looks like that top area has almost like a burn-in into the top layer of the fiberglass. So I'm hoping that's not touching a ground connection. So let's get some measurements. With our multimeter in resistance, let's check and see what the impedance of the entire line is now. Perfect. We are no longer 15 ohms. We are back in the kilo ohms. Now what exactly is this connected to? What is the measurement on here? 4.2. Now let's check and see exactly what that component is, or that specific pin. Where did my mouse go? There you are. Pin 3 is going to be graphics IMVP phase 2. Now, I feel like that's going to be normal just because that's going to be connected to phase power. But, of course, we have a donor board that we can reference to see if that is a proper reading. So, let's pull out our donor board. Alright, so pin 3, we were getting about 4 ohms. What are we getting now? Getting about 9. So it's still low. It's not exactly 4. About 9 on that side as well. So is it possible that it could have potentially killed anything else around it? Now also the donor board, it is a donor board. It's not a a board that is fully working. So it could be giving me a different reading because something else on the board is bad as well. Alright, it looks like that this may... let's check and see, because on the donor board we were getting 0.9 on both sides. We're getting 0.4 here. No, 0.9. Okay. So it's probably because the board was heated up. And 0.9 here. Alright, so I feel very confident that that exactly was our issue. I've never seen one of those components explode like that. Let's go ahead and get this prepped. So what we're going to do is wick up this area and put some new solder in its place. Now, I hate to say it, but without the thermal imager, I probably would have found that an hour later. It's a great tool, shouldn't fully rely on it, but it really helped us save some time in this regards. And any time that we can save some time and move on to another repair and help another client, I am more than happy. Alright, now that we have it wicked up, let's go ahead and apply some new solder. Alright, these mounds look bad. Let's touch it up. Need to apply a little bit more flux here. Perfect. And turn down our airflow here. And now we have our new Q8930 in place. Zentech says, whatever makes the job easier, I just use IPA. Isopropyl alcohol is a fantastic tool. I used to use it all the time for finding shorts. But it got to the point that we had weird pulsing shorts that were only like 30 Celsius. Not hot enough for the alcohol to truly evaporate. So that's why I ended up getting a thermal imager, just to help with those really, really tiny shorts. But it is definitely a great way of short detection. Okay. Let's make sure that these aren't shorted together, or, yeah, bridged together. That side looks fine. That side also looks fine. Alright, so that looks like that was a successful repair. Well, I should say, not repair, we shouldn't say repair just yet. But it looks like that was successful in replacing that. Admittedly, it doesn't look pretty, but in this case, I don't want to apply any more heat than I already have to the CPU and GPU area. So now we're just going to clean this up and let it cool down before we test and see if that fixed it. But yeah, I definitely don't narc on using isopropyl alcohol for short detection. It is a great tool. Just use a high grade, of course. Don't get the stuff that you can get from CVS or Walmart or your local convenience store. That's usually around 70%. So it'd be 70% isopropyl alcohol and 30% water. It's typically diluted. So anything I'd say above 91%, my preferred is 99%. Any way to eliminate any chance of moisture or water, anything that's conductive, the better. I just measured the voltage for each rail. I find missing rail, I find short. Yep, 99% only. Exactly. Alright, we're gonna let this board chill here for a moment. Meanwhile, I'm going to take another look at this underneath the microscope. And by this, I'm referring to my Q8930 that decided to turn into ash. Yeah, it just completely fried on the inside. So I'll give that about another minute, and let's check and see exactly what this is. So Q8930 is responsible for taking Graphics IMVP Boot 1, and it connects PPV and SO Graphics IMVP to PPV Core SO Graphics Phase 1. Actually, I was looking at this wrong. It looks like U-Gate comes out of U8900. Ooh, wait. Ah, hold on. Is this one of those boards that's known for having a bad soldered U8900? I think it is. I'll take a look at that later to see if maybe that was one, if that sent too much power. Although it looks like this was an internal failure on this specific component. Alright, so we have a U-Gate signal that goes to U8900, and it looks like it is a P-channel MOSFET in this case. And what it does is connect PPVN SO Graphics IMVP to PPV Core SO Graphics Phase 1, which will eventually make its way out to PPV Core SO Graphics Reg. Let's see, this line can take 25 amps max per phase. And where exactly does this go to on the rest of the computer? That's exactly what I thought. This is going to be our GPU V-core, which can only take a voltage of 1 volt. So hopefully this didn't kill our graphics card. Alright, we've had enough time to let this cool down. Okay, so one or two things is going to happen here. Either this is going to work, and then we're going to put it all back together and send it out. Well, a couple of steps in between. A quality control test, ultrasonic cleaning, another quality control test after that. Or something's about to explode. And the reason I say that is because it looks like that line, being that it was partially shorted, it could have, it doesn't look like in this case it could have sent too much power to the GPU power V core. We'll see what happens. Let's find out. All right. Are we going to get more than 0.3? 0.6, 0.8, 1 amp, 1.3, 1.8. Okay, it was consuming a lot there for a second. I got worried that it was just indefinitely consuming. But 0.7 to 0.8 is typical booting amperage. So this may have been successful. We're going to have to put our heatsink back on. And we'll replace the thermal paste once we know that this actually is going to work. And an ultrasonic cleaning, then the thermal paste, then reassembly. PCB layers look fine. Still, I'm nervous there for a moment. You never know when you're going to see something smoke, especially when you're working that close to the CPU and the GPU. But this is going to be one that I'm going to have to put on my spreadsheet of repaired boards, because now I know that when you pull 0.3 amps, doesn't always mean a dead CPU. That's been my record so far, but it'll be nice to put this one and add it to my internal database. Database. Tomato. All right, let's pull our board back out. I should have said pull our housing out, not our board. It's late. I'm just trying to peel some tape back. I swear, I always have the most difficult time putting these back together whenever I'm streaming. We take so many of these apart each day, but I only struggle whenever I'm trying to not get my head in the camera. So you don't want to see the back of my head. I don't want to see the back of my head. If I ever go back and watch these videos, and I'll see if I have hair loss. Come on. There we are. Don't make a fool of me, Mac. Alright. And I'm not going to screw all the screws in. I'm just going to float it in temporarily. and hook up a test drive. We will need to screw in one screw for our MagSafe board. And you know what, we probably should put one screw in each fan. Why not? And this is why we're doing a test. I actually left the, out of all the connections here, I left the backlight for the keyboard. Now I'm going to lift it up and pull it out anyways because the backside of the keyboard backlight connection is metal. I don't know what's on the underside of the board, but whatever it is, I definitely don't want to bridge it. There we are. Don't want that in there. And I'm really not too concerned with Wi-Fi, so I'm just going to leave the Wi-Fi card out for now. Okay, that is all I really need. Now I need to go grab a test drive. Alrighty. Let's see if this is actually going to show any image on the display. We're getting USB. So looks like the CPU is turning on enough for it to talk to USB, or at least send USB power. We are getting USB data now. You know what? Did I plug in the LVDS cable? I did. Now, that was graphic power. So truthfully, I'm not going to be surprised if there's not an image on the display. Let's see if we have any type of image at all. Fans are running high. That's an interesting symptom. Doesn't look like we have any image here. So we still have some sort of issue with our graphics processor. Curious as to why the fans are running high too. Everything thermal-wise is plugged in, thermal sensor-wise. So we got another issue still. Okay. Let's see if we have external display. Yeah. All right. So we're getting at least power from our HDMI, from our logic board to the television, but we're still not getting an image here. Now, I kind of want to address U8900 just because that's known for being an issue on this specific computer, and it looks like the power, I'm probably going to replace U8900 anyways, because the signal U gate goes directly to U8930, which was destroyed, and that comes from our U8900, which is just an all-around awful chip. Not necessarily the chip is awful, but the soldering on that chip is bad. So let's go ahead and take care of that. You're up and work late. Good luck on this repair. Thank you. Oh, I know who that is. Hey, good to see you. Long time no hear. Yes, it is still late. It's 9:37. Normally the only time I can take care of my board repairs. Alright, so let's pull this all back out again and see what's going on with U8900. Now, U8900 on these specific computers, you know what? I should probably check and see if we're even getting voltage for our graphics processor. Let's do that real quick before I fully pull everything out. Let's partially prop this open. .38 volts. I like the color of your shirt. Pantone blue. That voltage seems a little off. 0.38. Have to excuse me for a moment while I mute this to talk to my wife. Alright, and we're back. But yeah, that definitely seems to be an odd voltage that we're getting there, 0.3. That sounds like that's not even enough to be sending power, or not enough power. Still going to go ahead and take care of U8900 just because my logic before it's connected to the U89 or Q8930, so I wouldn't be surprised if that chip died. Hopefully it's just the chip and not the graphics processor itself. Old Navy, I guess you could say that. I just called it Pantone blue because if you watch HDTV, which I've done a lot in the last couple of years just to figure out what I wanted as far as a house goes, all the houses that have been built in the last 2 years use this same color that I'm wearing, and it's just the 2019 and 2020 Pantone color. I forget what the color is for this year. But there's like a whole color organization that comes up with that. And you'll notice like social media will use a certain color for certain years. I want to say the colors that we're seeing nowadays are very 70s. Very like mustard yellow and almost like a navy green. No, I meant the brand. Old Navy. Oh! I thought you were talking about the color. I have no idea, honestly. I think I got this shirt from Walmart when I was in a hurry to go somewhere and needed to change clothes. Okay. Let's take a look. at our board view here. Yep, U8900. So we're going to need to pull a U8900 from a donor board. In fact, let's grab a donor board from earlier. And interesting, this donor board that I'm about to pull from actually has the Apple certified repair. You can kind of see it's a little bit darker, it's a little bit more pronounced. And the reason for that is because there is some, there's a piece of rubber on top of our U8900. Right there. Oh, we don't need that menu. Right there. So that's definitely a good indicator that this is the computer that's known for having a bad U8900. Now let's go ahead and just peel off the Apple certified repair job. And I think that is a little bit of adhesive that's left behind. Let me see if I can scrape that off. Yeah, that's exactly what that is. There we are. Alright, so just like earlier, I'm going to go ahead and tin up the pads that are here with our low melt solder. I'm using my tweezers instead of my micro knife because my knife is starting to die. So I had to order a new one. It should be in here in the next couple of days. I prefer using the micro knife instead of the tweezers for that. Okay, and now I need to change out my nozzle because I had a small nozzle on my rework station for when I was doing an audio IC earlier today. But we're working on a MacBook, so we need a larger nozzle. Alright, got our nozzle on, let's heat up this area. And we want to pull this U8900 off. Hopefully this one is perfectly fine. So again, this is a donor board, so I'm not exactly sure why this board is here. I just know it doesn't turn on. But these chips should still be perfectly fine. So I'm sure most of you already know, but what the issue is with the U8900 is just the solder that Apple used just wasn't really good, and over time would kind of weaken itself, and these tiny little legs would break off. And when that would happen, you would lose graphics, or you'd have intermittent graphics issues. And the resolve for that is to just apply a lead-based solder onto the actual pins, or the legs, whichever you'd like to call it, of U8900, and that fixes the issue. But instead of actually putting a little bit of solder onto the chip itself, Apple just decided to apply a little bit more pressure by using that rubber piece of, Lewis said it best, a shoe grommet. Seems like the bottom of a shoe. Alright, so we got our donor U8900 ready. Now let's start working on our patient board. Need to change the orientation. So bottom left, the dot, that's going to be pin 1. We need to remember that orientation. And just like before, we're going to take some solder to help us melt these pins a little easier. Alrighty, let's start removing. And to help expedite the process, I'm going to just rub on the pins with my micro tweezers as we heat the area up with the board. Now the part that takes the longest to heat up is going to be ground. And the ground is going to be that giant square that's underneath the chip itself. Oh no! Alright, so we made a mistake. As you can see down here, we knocked off a couple of components in the process. But not to worry, we can fix that. Come here, little guy. We want you to go back onto your home. Okay. We can get rid of you. Alright, so to make things a little faster for us, we are going to borrow from our donor board, just because the placements on those components that got knocked off are going to be in the same area on our donor board. What happened was I didn't use enough flux, and when I pulled the chip off, my finger kind of slipped, and with it went a couple of components. Where are we? We are over here. I want that shirt. Can you get an extra large, please, bro? I'm pretty sure it's just a $5. It's a $5 shirt from Walmart. And the reason I'm doing this is because since I knocked those components off and they went into various places, instead of measuring every component and seeing which one is a capacitor or resistor and then what's the actual impedance of the resistor, I'm just trying to make the process a little faster by borrowing the pieces off the donor board that are in the same area. Now, that's because I had that little mistake. Like Bob Ross used to always say, we don't make mistakes, we make happy accidents. Okay, that's all loosely on there, but when we float on our U8900, our new U8900, that will fix all of that. So now, back to the repair. What we need to do now is wick up all the solder pads and put some new solder. I'm waiting for a beep. There we are. Oh, I just ripped off that component. Alright, not a problem. And what I mean by ripped off is I wicked up the component. You can kind of see it hanging out there in the wick itself. Come back here. There we are. Alright. Put you back in your home a second time. Okay, let's continuing wicking. And now we just have to put our leaded solder back onto our pads here. And we're pretty much ready at this point to go ahead and put our donor U8900 on here. Okay, so we remember that the orientation of pin 1 is going to be in the bottom left. Okay, so our U8900 is on crooked. So we need to fix that. Awesome. Now, normally this is where I would take my knife, my micro knife, and go around and touch at the edges. But, as mentioned earlier, our micro knife is kind of out of commission at the moment until we get a new one in. So we are going to use our micro tweezers instead. And let's touch up this component just because it did come off a couple of times. Okay, doesn't look like anything is bridged. That looks pretty successful to me. Let's just clean it up. When it comes to cleaning up flux, you definitely want to do it when the board is a little warm. As it starts to cool down, the flux starts to turn back into the equivalent of earwax, but whenever it is warm, it's a little bit more fluid and soaks up easier. Alright, so we're going to do an ultrasonic cleaning when we're done with everything, but that's enough for now. Alright. So now, I'll let that, well, it should cool off by the time we finish putting it back into our housing. Now, if this doesn't fix it, we're going to have to use our brain to see what else was damaged. Now, most of our clients are on spring break right now, and the majority of them said that they were going to Florida specifically. So what I've noticed recently is we are having an influx in iMac RAM upgrade. Now, whenever everyone reaches out to us about RAM upgrades on anything, first question is, why do you need RAM? Are you doing anything with graphic design? Are you using Photoshop or Premiere Pro? And surprisingly, the answers have been yes. And the reason why I ask that is because there's this misconception that replacing or upgrading the memory or RAM in your Mac will make it significantly faster. Now, I will say, you know, back in 2008, 2009, when I started messing around with computers, that was true because a computer at the time only came with 256 megabytes of memory. And in 2009, Windows 7 came out, and, you know, trying to run a computer off of 256 megabytes of RAM, it was just completely, it was just bad. So, you know, upgrading from a quarter of a gigabyte to 4 gigabytes was definitely a big improvement. So there's this misconception now that, you know, 8 gigs of memory in your Mac is not enough. So if you double it or even quadruple it and go to 32 gigs of RAM, it'll make it fast. And, you know, that was true, I would argue, 10 years ago. But not so much now if all you're doing is, you know, checking emails, going on Facebook. That doesn't, you're not going to see your performance increase by upgrading the memory. Ultimately, putting a faster drive in an older iMac, really even a newer iMac, like the 2019 iMacs, they still come with 5400 RPM mechanical drives, and Big Sur does not run well, or I should say APFS, the file system, does not run well at all on a mechanical drive. So upgrading to strictly solid state is definitely the improvement you'd want, or the route you want to go. But the clients that have been coming in have been actual graphics designers who do need more memory for Photoshop or for Premiere Pro, and that's just interesting in itself. So we're doing a lot of solid states and memory upgrades. That seems to be the big repairs we're doing this week. All right, so enough of that rant. Let's see if we get any type of image at all in the display now. All right, so consuming about 0.7 or 700 milliamps. I'm holding down the Option key. I don't see a backlight. And normally, because I'm holding the Option key down, I would expect to see a cursor. So I think we still have a further issue here. But at this moment, I don't hear the fans running as high as they were earlier. And let's see if we have any type of image and potentially just not a backlight. No image at all here. So what I'm going to do is now unplug the internal EDP connection and try see if we get an external display at all. I'm actually going to do a PRAM reset too. Alright, so the computer at least is posting. Alrighty, now let's look on our television that we have right here that you can't see to see if we have any type of external display. HDMI is getting power, but do we have any image on the HDMI? No image at all. So we are still experiencing graphics issues here. Another thing I'm curious for is, let's see how much voltage we are now getting on this specific coil, because before it was about 0.3 volts. We're getting nothing. Now, is that because we don't have the internal display port connected? Let's find out. Let's unplug our charger, plug in our internal display. This one's been fascinating because it originally was just not turning on. Now we got it working, but we don't have an image. So just because we have fan spin here doesn't mean that we have a fully working board. So now in that coil, before we were getting about 0.3. We're getting nothing now. With the power unplugged, let's see what our impedance is. 0.9, which is normal for that phase. Okay. We pleased Broad enough tonight. Let's see if we can use our brain for a little bit. It is pretty late, so I'm only going to do so much tonight, only because I do need to get some rest in order to properly get these repairs done timely, efficiently. So let's take a look here on our schematics and see what's going on. How's it going? Good to see you too. So this is going to be our PPV Core SO Graphics Phase 2. And before we were getting about 0.3, now we're not getting anything at all on it. And that was all part of U8900. Now, after we replace U8900, we're not getting anything. So, thinking one or two things happened here. Either the U8900 we have, it was bad, or maybe we're looking at a further issue. Let's see. The second thing being, maybe we're missing something like an enable line now. Yeah, let's check and see if GPU vCore enable is present. It looks like that's going to be on the back side. So we'd have to pull the entire logic board out. I think we got that shirt at Target or JCPenney. So much conversation about his shirt. Okay. Now that coil, L1398, is also connected to the same line as our PPV Core SO Graphics Phase 1. So if Phase 2 is not getting any power, Phase 1's also not getting any power. So excuse me. Either our graphics card is dead, or it's not getting an enable signal. So let's go ahead and pull the board back out. We'll spend a little bit more time, just a little bit more time. And this may be a board that I'm going to have to actually spend some time tomorrow doing. But the important thing is it's turning on. Now we just need an image. We can't send this one out the door just because the fan's turning on. This shirt, I'm pretty sure we picked up whenever we went over to a friend's, what was a bachelor party, and we were in a hurry and needed to just grab something from a store. So I'm pretty sure we just picked this one up for Walmart, just so that we weren't wearing any just dirty clothes from the previous day. So if the graphics processor isn't getting any power at all, we need to find out if it's even being told to turn on. And once again, this U8900 could be bad because it did have a piece of rubber on it whenever we pulled it off of our donor board. It could also be improperly soldered. I don't know, you have so many blue shirts, it's like we're on a mission to collect one from every store. I like the color blue. Let's take a look at our joints here. Everything appears to be soldered on just fine. And the components that we knocked off look to be on just fine as well. Okay. Let's see exactly where that enable pin is. GPU vCore enable. And I think the batteries in my mouse is starting to die. Okay, so that pin is going to be pin 38, and it goes directly to the SMC on U9100. Is that the SMC? It looks like one, but I don't think it is. No, it is not the SMC. So let's check this resistor right here or this pin right here for GPU vCore enable. Okay, so pin 38 is going to be this pin right here. And that line appears to be missing. Let's unplug that just to make sure we don't bridge anything. Okay, so we're missing an enable signal. So if the enable signal is missing, U8900 is not going to turn on. So now, with the power unplugged, let's make sure that the enable signal is not shorted, that we didn't bridge something when we put this back on. 10 kiloohms. That's not bridged. So something is not generating a signal for U8900 or for the enable signal. Where's the charger for the iPad? There's nothing over here. Check by the bedside table. It's going to be on my dirty hamper of clothes. My dirty hamper that has my clean clothes. Alright, so GPU vCore. GPU vCore is going to come from, it looks like U9100. Why is the computer running so sluggish now? U8900 is going to be DisplayPort Mux IC. But why would that stop working all of a sudden? Could that have also died from when we had that U8930 explode? Or is it possible that these pull-up resistors right here could be bad? Connect I2C to LCD backlight IC. U8900 looks to be responsible for quite a lot of things. But what we want to know is where exactly does the enable signal come from? External DisplayPort MUX. So it's a MUX chip that is responsible for sending power. Okay, let's see. vCore enable, and we want to see where GPU vCore enable is coming from. Thanks, it was hiding. Okay, it looks like we have a couple of different things that go from the GMUX. We have 1v1 GPU enable, 3v3 GPU enable and GPV core, as well as PM all GPU P good. Interesting. So I wonder if any of these other signals are present, but let's check and see where GPV core even comes from, or GPV core enable comes from. Okay, we see it going into U8900. Looks like GPU rail sequencing. Kepler GPU requires rails to come up in the following order. Okay, so GPU 3v3 needs to be present before GPU vCore is going to be present. All right, let's put a pin in that, and we'll come back to that in a second. That's going to be page 99. But I still... Okay. So let's check and see if PP3v3 GPU enable is present. Okay, we have a couple of different components right here. But is there anything on the back? Perfect. There's a resistor right here that we can measure. Let's check and see if we have an enable signal coming from PP3v3 GPU enable. So these resistors right here are part of the MUX. Put this back into voltage. We don't want to measure the resistance of a circuit while it's on. And it looks like it's going to be the third resistor down from the top. So that would be this one right here, because technically that one up there is still a... what's the word I'm looking for? Where a resistor should be, it's a no stuff. And we have 0. So, right off the bat, that is missing. Let's check with power unplugged, the impedance. This very well could all circle back to just being a bad U8900. Back in the 10 kilo ohms. That's a very interesting number. I'm going to reference that to our donor board. 10 kilo ohms sounds like an actual measurement, but the fact that our GPU enable was the same thing, it just seems like maybe something might be bridged, or this is just a bad chip. 10 seems fine there, and where the enable signal is actually coming from for GPU vCore enable 10. All right, so we'll look at one more rabbit hole and then end up replacing that U8900. Okay, so we can see this line, PP3v3 GPU enable, is going to come from egg rail enable. 1.8 volts may not be required for Kepler if no LVDS. So, we're now looking at a coin toss we're going to have here. Either U8900 is bad or U9100 is bad. U8900, before we replaced it, we were getting a reading of 0.3 volts on our CPU phase line, GPU phase line. But now we're not getting anything after replacing it. We can try replacing it one more time, and if it still doesn't work, then it looks like we might actually have an issue with our MUX on U9100. Or we could have a dead... No, right off the bat, I'm not going to say it's a dead GPU, mostly because we're missing an enable signal now. So, let's get another U8900 from another board. So it is a 62882C. And we have one right here. My bet is solder job. The pins looked fine. I can take another look at it, but I have a feeling that the U8900 might still just be bad. Especially because this one was the one that had the Apple shoe rubber on it. Now granted, I don't have my... Ooh, that looks a little suspicious. Now granted, I don't have my, like a working micro knife for actually going through and touching up the area. All of that looks solid. For the most part, the joints all look fine. So another thing I was curious about, I'll take a quick look at. Did we not? Was there any other components that we needed to replace that we knocked off? Oh, everything looks to be there. Alright, just double checking. So let's go ahead and replace this U8900. So this one's from a different year. We can see that Apple tried fixing it by using mask this time. Or an underfill, I should say. So this stuff, in order for us to remove it, we have to heat up the board. And then we're going to take our scalpel and just cut along the edges. Definitely got to get the graphics card working on this one, because I just remembered this guy is an artist. So the irony of the graphics to mess up on an artist I find to be amusing. So we're going to get this one working. Alright, so the underfill has been removed. Let's go ahead and apply our flux. come on. So that one came from its home, off of its home. Thank you, donor board. We'll set you to the side. Now, this U8900 should come off no problem, since we have our low melt solder on here. It's interesting, though, the types of repairs we get in the waves that they come in. Because last 2 weeks, actually, most of March was nothing but iPads. iPad screens and charge port replacements. We had a few today, battery and charge port, but now the new trend, though, is the iMacs, the SSD upgrades and RAM upgrades. So I'm curious what's going to be the main repair in May. If I had to call a bet on it, it's going to be liquid damage data recovery. Now that everyone is going spring break, everyone's down in Florida, that's what I see happening in the next couple of weeks. Because we've already had a fair share of liquid damage devices already come in, and I don't offer liquid damage iPhone repair anymore. Too many late nights spent trying to fix a device just to find out that the CPU was dead, or we'd fix it and it'd have another issue 2 weeks later because of the liquid damage. But if you need data recovery, we can definitely help out with that. But the strangest liquid damages, though, like salt water damage in a MacBook. And it usually happens when people take their MacBooks to the beach with them. Thank you, Tech Tree. Alright, so we just need to get this lined up a little bit more. Now let's clean this up with our micro tweezers. Now, looking at it, the chip looks like it's still on there a little crooked, so while it's hot, heat it back up and kind of let surface tension pull the board back in, the chip back into place. And so I'm just adding a little bit more solder onto the actual joints themselves. And this one joint looks a little off. There we are. And now I'm just going to clean it up and check and see if the pads actually look alright. It's just a little mound. Just a little mound, nothing to worry about. Okay, now this is the part where everything gets a little out of focus on your end, but I just want to examine to see how my pads look. Those pads could be a little bit better, but they are connecting. Same thing there. Those pads are connecting, but they could be better. And there as well. So at this point, all the pads are connected properly. We just need to find out if we actually are going to get GPU vCore enabled. So the board has had a little bit of time to cool down. Let's hook it back up to our MagSafe power and see what we get. Change our multimeter back into voltage and see what that pin exactly. It was pin 38, and see what kind of reading it gets. And we're still not getting anything. Still not getting anything on our PP33 GPU enable. So I'm curious if any of these components that I knocked off, if they are, what's the word I'm looking for, if they're not reading like they properly should. Because once again, we did have a partially working, I guess you could say it was a partially working U8900, but now we have nothing. Let's take a look here and see, it's 1040. See how much more I can get done before we end up calling it a night. So let's see what these components are. This may be a situation where I was trying to make things a little bit faster for me, and in the process I actually slowed things down. Alright, so these are capacitors. Let's make sure that they are actually good capacitors. Okay, reading about 5,000 kiloohms, which makes sense because the resistor R8914 is a 5,000 or 5 kiloohm resistor. So that one looks like it's okay. Okay, that one is capacitance like it should. Same thing here. we didn't even really do anything with this resistor. About 8 kiloohms. That's going to be our feedback line. Eight kiloohms is correct. Okay. Graphics IMVP NTC, not connected. Supposed to be 30 kiloohms. Check and see what we got here. About 30 kiloohms. This component came off twice now. It is 146 kiloohms. That seems a little odd, but let's check and see what that is. $147 kiloohms, so that's absolutely fine. And this A1398, it's not present, so let's make sure it's a no stuff. No stuff, which means it doesn't exist. So it doesn't look like any of the components that we had knocked off are not compatible. What about R8972? Is that a no stuff? That is also a no stuff, so it is not present. Interesting. Okay. So maybe we still have a further issue because we're still getting the exact same thing on this U8900. Then again, we did say that the pads weren't the best looking. Alright, so my micro knife isn't working like it should, but in this case, I'm going to try to put it back on and see what happens. Because the joints weren't the best looking. And if it's still not working, then it's possible that our Gmux is also failing as well, because of that Q8930 was massively shorted. Just don't want to deem this one a dead GPU just yet, because the GPU is not even turning on. Well, we just need to get our U8900 to warm up a little bit more so we can move it over. As I mentioned, some of the joints don't look aligned right. They are definitely making connection, but they're just not the prettiest. So all of the pads are pretty much melted at this point, except for the ground pad. So I'm having to just play with that. Okay. Now let's get our broken micro knife. It's taking forever to heat up since it is dying. And add a little bit more flux just so we can make some nice connections, because the left side looks a little off, but of course my camera or my C-mount makes that whole left side blurry, so you can't really see what I see. The left side's the only side that looks a little suspicious to me. Everything else looks pretty good. So let's take a look at that left side underneath the microscope. Okay, those pads are on solid. Much better. So, at this point, it doesn't look like it's going to be an issue with the solder job. Yep, all that looks much better. Alright, now let's take a look at that GPU enable again. Still not getting any signal at this point. Very peculiar. And very, very peculiar. Let's see if we have that PP3v3 graphics enable. Still nothing there. So at this point, it doesn't look like it's an issue with the U8900. So these are always fun. We have resolved one issue, and only to find another issue. And the main issue was the computer wasn't turning on. Now the computer itself is just not sending an enable signal to the GPU, so the GPU is not turning on. Alright. So at this point, I think what we're going to do, since it's almost 11 o'clock, and this stream's been going on for about 2 hours, is I'm going to go ahead and call it quits here. I'm probably going to have a part 2 of this, just because I want to go ahead and get out of here so I can enjoy the rest of my evening. And then we will see why exactly this is no longer getting an enable signal. I'm curious if it has something to do with the Gmux, just because the issue that we had here originally was we had an extremely shorted Q8930. Now, Q8930 is going to be a transistor that comes right after our U8900, and its sole purpose is to connect our PPVN SO graphics IMVP to our PPV Core SO graphics phase 1, which eventually makes its way to being PPV Core SO graphics regulator. This is going to be the actual power supply for the graphics card. When we replaced it, the computer was turning on, and we were getting a very low resistance of 0.3. I'm sorry, not resistance, a very low voltage of 0.3. So we went ahead and replaced our U8900, just thinking maybe this isn't sending out the right signal, and now our phase lines, we're not getting any voltage, which kind of gives me an indicator U8900 is no longer turning on. So U8900 has a GPU vCore enable line. This is going to be the line that creates, basically it's the switch that is going to turn on our U8900. Now there's probably something obvious I'm missing here, because we also have like a clock enable line. We have a boot line, which I think that comes after the device even turns on. But we can even make sure that it's even getting the proper power. For instance, this component right here, which is conveniently next to our U8900. This is going to be part of VDD. Anyways, after removing our U8900, it seems like it's not even getting a P-good or a GPV core enable signal, which if we check that, that goes all the way to U9100. Now, is it possible that U9100, which is going to be our graphics mux, is it possible the Gmux, which is kind of responsible for creating power in general, or kind of switching back and forth different voltage lines, is it possible that when we were getting that weird reading of 0.3 volts, was it because the graphics mux was failing, the DP mux, display port mux? Is it because it was failing, and we resolved the issue with U8900, did it just finally basically kill itself, the U9100? This is where things get a little complicated, because we're trying to figure out what is the issue, and what is something that we went back, some donor boards moved on their own, what is the issue, and what is an issue that we may have introduced or changed? The fact that we are getting a different voltage after messing with U8900 makes me think there's something wrong with our soldering job. But we went ahead and we replaced U8900 a second time, getting the same resistance. Out of curiosity, just because my finger did slip earlier, is this resistor, let's see, where did it run off to? For VDD for U8900, was that even present still? That was going to be resistor R8901. I don't see why we would have touched that, because that would have been over here on the right side, and that's still there. So, before I go any further down this rabbit hole, we're just going to go ahead and end it here for now. But at least we got it working. Now we just need to get the graphics working. So, I hope you all have enjoyed so far what we've learned, and hopefully we can get a part 2 of this and get this one up and running. So, thank you for joining me this evening. I'll see you guys in the next one.